Sorry for that interruption. Someone came over the intercom, and I had to interrupt the recording. So we just finished talking about linear triatomic shape. Now we're going to talk about trigonal planar. So in this case, you've got a central atom with 3 constituents around it, and our example is going to be boron trihydride, so that would be boron in the middle and 3 hydrogen atoms around the perimeter. They distribute themselves as far away from one another as they can. In this case, there is there are a single unshared non-bonding pair of electrons, but it doesn't affect the way these 3 covalent bonds distribute themselves around the molecule. So the result is that you have this, it's a planar molecule. In other words, it lies in a single plane. There's the 3 hydrogen atoms in this boron trihydride example are all in the same plane, and that's, I think, actually easiest seen here in this particular structure. So the example here is boron trihydride. The name is trigonal planar, and you don't need to worry about the bond angles for this one. The final shape that we're going to look at is called trigonal bipyramidal, which is kind of a fun word to say. I suggest you try saying that 5 times really fast. Anyway, this has 5 pairs of electrons that are associated with bonds, and then a single pair of non-bonding electrons, or an unshared pair of electrons. The distribution of the 5 covalent bonds around the central atom is unaffected by the lone pair of electrons. So the example here is phosphorus pentachloride, where there's a phosphorus in the middle and 5 chlorine atoms around it. And the distribution of those chlorine atoms is unaffected by the lone pair of electrons. Okay, so in this case, in this type of shape, the shape is really driven by the number of covalent bonds and not by the lone pair. All right, and so what you need to know here, trigonal bipyramidal, example is PCl5, phosphorus pentachloride, and you don't need to worry about a bond angle. All right, that's it for VSEPR. We will be doing an activity on this tomorrow, so make sure you print out the molecular activity hyperlink from the webpage, and have a good night.